because length and mass cannot be formed only by h and c dimensionally. It has to be related somehow, either like length, like this. It has to be like this, inversely proportional. And then he suggested, well, since length is more sort of intuitive to us, so you should introduce length as the fundamental length, instead of a kind of fundamental mass. So if we see this structure here, and it resembles the kind of curvature formula in mathematics. If you simply take, well, if this is curvature and this is radius of curvature, it's inverse proportional. And then if you take the action of electron as unit and the speed of light as unit, so you can identify curvature with the mass and the radius of curvature with the radius of the structure. So from one example, you can expand the concept to a general meaning. Well, we can see how valid it's going to be. But in a way, it makes sense because the heavier the mass you have, the more curved the space you have. And also, the heavier the particle, the smaller the particle. In a way, it makes sense. And then I also checked the transformation properties of the structure. And not like Lorentz transform or other, but just three discrete transformations. So charge parity and time reversal. It turned out that since you have the charge associated with the twist, in other words, associated with parity, so the charge parity will not be individual or independent operations. It's going to be one combined operation. So this one will become one operation, and time reversal operation is still independent. And these operations form like a commutative operation. You can act this one first and then that one. And then the way of defining left and right is also different. Because in this case, the left is not the right. When we see our hands, it is not, because there is a mirror symmetry associated with it. I cannot move my left hand to my right hand, except if I put my right hand in the mirror. That's basically says right is not the left. Or if you somehow inverse right, it will not be inverse left. But rather it should be the inverse right is left, and the right is inverse left. Hopefully I didn't really come up. Yeah. So then this was basically content-wise. It was basically the first version of the paper. And then I submitted to a journal, and I got criticism. They said, "But everybody knows electrons are points, so you cannot have this one with quantum wavelength." And so then I said, I thought, well, I have to explain why. Say, if you have such a large electron, when you do high energy scattering, you see them as a point. And then I wrote an additional section there. You can see here. And for every particle, we have this relation. And if we put this relation to the electron in this one, we have also this relation. So then, if you replace mass with this one, what you get is the size as a function of energy. So the higher the energy you have, the smaller the size you have. That means when you collide two electrons of very, very high energy, they are already very, very small. That's why when you analyze your data, you see, well, they are very, very small, 10 to the power 16 if you get to 200 gig electron volts. So then we come to some implications of the work, which is not so tightly related to the structure. The first thing is, because of the finite size, you get a finite self-energy and self-mass, not like classical electrodynamics, where if you R approach zero, there will be a singularity. And then You can also try to categorize particle, because for this one it's half spin and it has 2 turns. But if you have 1 turn, you have spin of integer, and so on. And here it's also possible through this relation and the relation to the fine structure constant to introduce fundamental length. So, yeah, well, now I've looked through the statement that this structure has been overlooked. People have not, in my understanding, people have not noticed this 2-turn helix thing. Rather, they have seen this one a lot. I think in almost all calculus books you can find Möbius strip, the essays, a kind of very interesting example to inspire students. And like in mathematics, in art, and you find a lot of hits if you go to Google it. And even this is Möbius strip is the non-trivial Fabio-Bando in terms of Fabio-Bando theory. So yeah, there's a new book written by Clifford Pickover that's specifically talked about Möbius strip. It's going to be published quite soon, so we'll see it's quite an impressive book. He claimed to write 1 book a year for some topics, different topics. Yeah, there's another aspect which you recognize is knot theory. So when you see the first, like, classification of knots, the first 5 knots, this is not knots. And then the second one is this one, the knots, like knots table. Well, I claim there's something missing here, because as you said, you have this one, right? Knot, knot, knot. And this is something between knot, knot, and a knot. If we say knot, 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 it's not knot. So this is something exactly in between knot, knot, and the knot, which is this structure. So that's one should disappear. So you see, first of all, you have one simple ring, and then you make a trophoid knot. But in between, actually, this one should be there. But nobody.
Topologically, this would be the same as the first.
Yeah, that was a problem. But because this one, well, it depends how you say it, right? But this is a 2-dimensional object, and this is a 3-dimensional object. You can, well, that's why when people start a topology, they restrict themselves to 2-dimensional space. They say, well, what's special if you make another term? Because I mean, I can draw millions of circles. It appears it's still one. But if you lift yourself to 3 dimension, then it will be different. But you still think topologically equivalent?
In fact, topologically, look at the complement of the knot, and that is the complement of the knot depends on the embedding.
Yeah.
That's a topological.
So what does that mean?
It means that your argument is true. If you embed it in a certain space,
yes,
the complement is different.
Yes.
And you look at the complement as a topological thing for the knot.
Yeah. Yes. Yeah. Let me cite. Well, one thing I found from Bohm is that physics is a form of insight. As such, it's a form of art. So, because in trying to understand this object and its relation to Möbius strip, it took me like half a year to see what is actually these things are. So I would like to comment on something about this ambiguous figures, and I call the coupled double perception. The 2 examples. The first one is an ecotube. I think these are well-known things. Yeah, but well, if you look at this for a while, then these things start to jump, because